back to a new section of Math Online, whatnot. All right, let me fix something real fast. Can I hear myself a little bit better? Okay, cool. Today, we're going to be talking about linear relations. Come here, bub. Here's Bo. Yes, your wonderful teaching assistant, your TA for the class. We're going to talk about linear relations today. And I got kind of excited. I know it's a little bit late tonight. Well, I guess, yeah, it'll be posted tonight, so no big deal. It is approximately 11 o'clock p.m., but I figured out how to post PDF onto PowerPoint, or onto Photoshop, so that's good. Why is your pause though? Go hang out. Go hang out somewhere else, not with me. I know. Okay, so today we're going to kind of go through this kind of stuff, and we've got a lot to cover, so this might be about the same length as the last video. Hopefully not overall. So we're going to say we're writing keynotes. Okay, so today is about linear relations, and you can pause this at any time if you want to read any of this. These are the notes that I go off of for the class. These are notes that I have acquired through a different curriculum. But yeah, we basically will follow these along pretty well, so no big. When points in a graph lie along a straight line, it's called a linear relation. So that's just vocab for you right there. No big deal. Right here is just vocab. Just understand linear relations. Okay, linear obviously means line, right? And then relations, we've already talked about what relations are. So they have a lot to do with functions and whatnot. But regardless, we're going to move on. Linear relation can be represented as an equation. For example, the equation of this graph can be written as x plus y equals 8. This is the graph that is shown there. So this is shown right here, right? I'm trying to draw an arrow, but that's pretty bad. X plus y equals 8. Good. Linear equations are often written in standard form. So standard form is, I mean, you've seen this a lot. I'm going to write down, so ax plus by equals c. And I'll be honest with you, that's not the hard part, okay? That's one of the many, many equations that you're going to have to memorize. So standard form ax plus by equals c. Good. And of course, a, b, and c, those are just variables, specifically integers. Hopefully you remember what integers are. We're going to try not to work with any fractions, which some of you will be happy about there. Cool. The biggest rule, however, is this right here. When a, b, and c are integers, and a has to be greater than or equal to 1. And you can manipulate stuff to make a greater than 1. That's not that big of a deal. GCF is greatest common factor, of course, of a, b, and c is 1. So we want to make sure that we're simplifying down. That's what this is saying. So don't even worry about this. Just basically say simplify. Awesome. Hopefully you guys can see that. Great. Let me check real quick how we're looking. Oh, we are looking gorgeous. Hopefully you like my hat. I'm in not at all school attire because it is 11 o'clock at night, and right after this, Mr. McMahon is going to bed. So write each equation in standard form. So first off, let's just do this number 1. We're going to skip around a lot in this. I'm going to only do a couple of these. So this -5, as we see, right, we already did not follow the first rule I was telling you was very important, right? The a has to be greater than or equal to 1. -5 is not greater than or equal to 1, right? So how am I going to change that? I'm just going to divide the whole stinking things, everything in this, by -1. And if I do that, I'm going to start finding a solution, finding actual standard form. So 5x plus, oh, not plus, what am I doing? I just did this. Minus 6y equals 12. This time, I did it ahead of time, so I'm not having to do math in my head. I think I made a mistake last video, but don't tell anybody. Okay, cool. So now this is standard form. This is written in standard form. Yay, we did it. That's it. That's the whole thing. It checks out, right? It is as simple as it can go. 5, 6, and 12, none of them are related. 5 is greater than or equal to 1. Everything checks out. So this is A. So my A is right here. This is A. This is my B. And this is my C. Cool. It's very important that you start understanding A, B, and C because we will use that a lot, say, in linear regression. It's going to be a great time, let me tell you. That's not sarcasm. Okay, so I obviously have, so let's just do, I don't know, number 2, I guess. What I'm going to do is You can do it one of two ways. You can add the 9 over, subtract the y. It doesn't really matter. I'm going to try to keep the 2 here positive. So I'm going to move this 9 over here. Cool, so this becomes y minus 9 equals 2x. Then I'm going to move the y over, minus y, minus y. So in the end here, make a little arrow, we end up getting 2x minus y equals negative 9. Oh, I didn't plus it. Son of a gun. Plus y, or plus 9. So that's actually a positive 9. So in this particular case, Mr. Man sucks. So, that's fine. I need to fix this. Positive 9, right? 2x minus y equals positive 9. All good. I actually did not do this one beforehand, so that's a doozy. Plus 9, good. Hopefully that kind of makes sense, because again, this is our A. A is 2, our B is negative 1, and our C is 9. Sweet. This is standard form. Awesome. Yeah, let's do this one. Okay, so obviously this is not quite in standard form, right? AX plus BY equals C. I need to get into that. So obviously my A is right here. This is my A. This is my B. And this is going to be my C, but my C has to go over here. So what I'm going to do is I'm just going to add 24 to this side. Cool, and I've got 9x plus 6y equals positive 24. And technically speaking, we're so close to being done. We've done everything that was difficult except for one particular thing, and it's right up there in blue, right? We still need to simplify this as much as we can. And we can take a 3 out of all of these, right? So the final solution ends up becoming 3x plus 2y equals 8. Sweet. That's our answer. Done. That's standard form. I guess we can do another one of these. Let's just worry about... Let's do 6. 6 looks stupid. Well, first off, I see a fraction. And that's already failing our... Can you see 6, hopefully? Oh, yeah. Plenty of room. Okay, so that is obviously less than this 1 right here, right? So A is greater than or equal to 1. 1/6 does not help us, so I'm going to try to get rid of that fraction. And to do that, all I have to do is multiply everything in this problem by 6. So I'm basically just going to be bracketing this, multiplying everything by 6. Because that's going to get rid of this, and it's just going to make it so I have to times 6 into here. So I end up getting x equals 6 times y minus 2. So I'm going to rewrite that as x equals 6y minus 12, because I'm distributing this 6 into here. And I'm just going to move the y over. I'm going to subtract this 6y over to here. So I'm left with x minus 6y equals negative 12. And that's it. Sorry, pause. Got the sniffles. Done. That's it. That's literally standard form. Shouldn't be too difficult. We can't do anything else here. A is 1. That's good. Negative 6y and then equals 12. It all checks out. All right. If you have any questions, feel free to ask me in class tomorrow. Do not worry too much about it. Now we're going to move on to slope-intercept form. Slope-intercept form is very important. Okay, so how we write slope-intercept form. So the biggest one, the one you probably know most, is y equals mx plus b, right? Or we can technically write it just like we did last time. The f of x can replace y, so it could still be a function. Actually, every linear equation is a function, so that's good. Where m is, of course, the slope, and b is the y-intercept. I forgot how to spell intercept. I'm trying to think about that. Intercept. Sure, whatever. Y-intercept, right? It's where it connects at the y-axis, that basically vertical axis. Slope is a constant rate of change between points. Think rise over run. This is a big thing. If you want to put that in your notes, that's huge. Rise over run is massive. You will use that forever. There's actually 4 types of slopes. This is cool. Sketch them below. Okay, let's think. So we have a positive slope, a negative slope. We've got a 0 slope. We've got an undefined slope. I did not fill these out prior, but we can figure this one out. So I'm going to pretend like, oh, wait a minute. This will be hilarious if I don't have any graphs. Oh, I've got graphs. Okay, good. All right, positive, a negative slope, a zero slope, and an undefined slope. So let's draw this all in a color that we can see. Let's do this really bright blue, or I think it's dark, but whatever. A positive slope looks like this, right? Rise over run, we go up one, over one, up one positive, to the right one, so positive, no big, positive slope. Negative slope looks like this. It's going downwards. So you go down one to the right. Down one to the right. Or in this sense, you could also be going up, but to the left. So a negative slope. Zero. Zero slope is very important. That is this. That's a that. An undefined slope looks like this. And the reason why it does this, so zero, for instance, here, this is saying we do not go up anywhere, right? So actually, I'm going to zoom into this a little bit. Oh my gosh, wait a minute. Can you guys, I really hope you guys have seen all that. I think so. I'll scroll down. That's a positive. That's a negative. That's a zero. Fine. All right, I'm going to really focus in on the zero, though, okay? So with this function, I'm not going up at all, right? I'm not going up and over. If anything, I'm not going anywhere up. So it's rise over run, so zero rise and whatever run. 0 divided by 1 actually just equals 0, and that's fine. Now if we look over here at the undefined part, that's where it gets a little bit tricky. This is going up, right? So it's going like up, say 1, and it's not going over anything. 1 over 0. Now if you take a calculator, I can probably show you. And if I do 1 divided by 0, rise 1, go up 1, over 0, so don't go anywhere, right? Cannot divide by 0, so that's why it's undefined. If you want to just memorize that vertical is undefined and horizontal is 0, by all means do it. I do not care. Okie dokie. That should be pretty good on that factor. All right, let's real quickly erase all this, though. Let's do that real fast while we have the time. And feel free, again, you can pause this at any time you want to. Anytime at all. I am 100% okay with... Oh no, did I just lag? Oh no. This is hilarious. I guess we'll pause it right now. And we are back right now. Boom, perfect. For another round of mathematics. Great, it was just a nice little lag. This is a big program, and we are running it on a computer that probably shouldn't be running it. Cool, so write the equation in slope-intercept form, then graph the line. Awesome. Let's do this first one. So my slope exists right here. So again, I'm going to write, hopefully, can we see? How far can we see over? Pretty far. Y equals mx plus b. Y equals mx plus b. Can we see that? Yes, we can. Cool. And that's what we're kind of going for, right? We know this, so my m is my slope, my b is my y-intercept, so this is m. M equals 2 over 5, and then b, my y-intercept, equals 7. So at 7, I'm going to zoom into this guy. At 7, so 1, 2, 3, 4, 5, 6, 7, we know that this crosses, so there's going to be a dot here. There's going to be a slope of up 2 over 5. I'm not going to go this way, though. I'm going to go down 2 to the left 5. 1, 2, 3, 4, 5. Boom. And you really only need 2 lines. If you wanted to go more, that's okay. So in this case, we look like this. And that's my graph. Wow, that's that easy. Easy peasy. You guys have done this 1,000 times. So this one, my y-intercept is 2. My slope is -1. So m equals -1, b equals 2. So right here, and then I go down 1 to the right 1, down 1 to the right 1, up 1 to the left 1. So we have this nice and easy negative slope looking like this. Obviously, this is a negative. It's facing down. It's going downwards. This one's a positive slope. It's going up. Great. Let's do this one. This one seems fun. This number 10 right here. This is almost in what? Standard form, right? So what I'm going to do instead, I'm going to try to get a slope-intercept. Slope-intercept, of course, is y equals mx plus b. So my y I'm trying to get by itself. So I'm going to add the 1 over here. Then I'm going to subtract 4x also over here. So I end up getting y equals negative 4x plus 1. Y equals negative 4x plus 1. So my m equals negative 4. So I'm going to have a downward sloping slope. And then my b equals positive 1. So plus 1. Don't know why I had almost made it negative. But okay, so at 1, right there. Looking good so far. And now I'm going to be going down 4. 1, 2, 3, 4 over 1, because this is the same thing as saying negative 4 over 1. I'm going to go up 4. 1, 2, 3, 4 to the left 1. Now we look like this, right? Perfect. And that's all you'd have to do for those, okay? Just get it in slope-intercept form, y equals mx plus b, graph it, call it a day. Great. And, all right, so let's do some of these little more difficult ones, even though these aren't too difficult. So vertical and horizontal lines. So what this is representative. So what kind of slope is this again? We just saw it earlier. So this kind of slope is an undefined slope. Slope is obviously undefined. But what this shows up as is x equals, I don't know, what is that, negative 3, right? So 1, 2, negative 3. So when x equals negative 3, this is the graph for it. Boom. That easy. Because I can't plug anything else for x in, right? X is only negative 3, so all the y values exist for it, so it goes up and down. Not an issue. What am I doing? Stop it. This. Okay, so this one is obviously y is equal to 1 instead, and that's where we get this. And the slope here, so slope is 0. Cool. That's good because, again, you're not going up any, so it's 0 over 1. This one is 1 over 0 type slope, which is undefined. This one is defined. Hopefully we understand that. Okay. Let us parallel versus perpendicular. That's fun. I know we're flying through this, but you can pause at any time. Try to see what you can do. I'm going to post this on our Google Classroom, like the whole thing filled out, so don't worry about that. This is just a real quick video. Slopes of parallel lines, excuse me, are equal. Okay? So y equals 3x plus 1. The parallel line to it is y equals 3x plus 2, right? They will go up at the same rate. They will have the same slope, rise over run, but they just won't be connected. They're just right next to each other. So they have an equal slope. Slopes of perpendicular lines are opposite. Reciprocals. Yeah, right? I think it's probably an O here and an A here. Whatever. I'm not an English major, so it is what it is. Opposite reciprocals, or also considered negative reciprocals. That's fine. I do not care which one you use. Opposite or negative works for me. So an example of an opposite reciprocal, so it could be y equals 3x plus 1. The perpendicular will be y equals negative 1 over 3x plus 1. So it's like inverse, but both additive and multiplicative inverses. We've done those before. So no, Blizzard, I don't want to play World of Warcraft right now. Get out of here. Okay. Great. Determine whether the pair lines are parallel or perpendicular. My best advice to you is to definitely get them in slope-intercept form. So, again, slope-intercept is y equals mx plus b. So I end up having this. So I'm going to, first off, I'm going to take everything divided by 5, just because I want to get it reduced down to whatever I can. So this ends up becoming 2x plus y equals 1. So when I move this over, I get y equals negative 2x plus 1, because I'm moving everything over. Good. This guy right here, I'm almost already there, so I'm going to basically move the 6 over, so I'm left with negative x minus 16 equals 2y divided by 2, divided by 2, divided by 2. So y ends up equaling, what is that, negative 1/2 x and minus 8. Now, if you notice, so what we have to look at is the slope, okay? So these are my slopes right here. And if it was positive 2, the opposite reciprocal would be negative 1/2, right? But in this case, this is not the opposite reciprocal of this guy right here, so this is neither. This is neither perpendicular nor parallel. Okay, let's look at this guy. Okay, so first off, I'm going to move the x over. That's what I'm going to do first. I'm leaving with 6y equals negative 8x plus 42. I just manipulated this kind of stuff. I'm going to divide everything by negative 6. Good, so y ends up equaling, so positive 4 over 3 x plus, and I am way too tired right now, so let's just pretend that we know how to do this in our heads. 7. I knew that one. Dang it. But it's not. Oh, God. Okay. It is not positive. It is negative 7. Good. Now I divide this by negative 3. Negative 3. Negative 3. Left with y equals. Okay. Oh my gosh. Positive 4 over 3 as well. Minus 3. Which I hope that was right. Let's see here. Maybe I didn't do that one right. I think I did. Oh my God, I'm an idiot. All right. I'm too tired for this. But anyways, if you notice, positive 4 over 3 is the slopes. So obviously, parallel. Parallel. Looking good. Oh, good. Good. Parallel lines. Yeah, and if this was negative 3 over 4, that would be perpendicular. If this one right here was negative 3 over 4, it'd be perpendicular. Great. I think that's about it for that one right there. I think that's looking pretty good. How much time we got on the clock? How much time has this one been? 22 minutes? All right, we can do this. We can get through this. Not a problem at all. Let's delete this layer that we wrote on. Then let us add another layer to write on. All right, zoom into this pupper right here. Boom! X-intercepts. Oh my gosh, I'm gonna write all this out. Don't worry about this stuff. We're gonna worry about that in lesson or unit 4. Who cares? X and Y intercepts are super easy. All you have to do is just plug 0 in for the one you're not trying to find. So if I'm trying to find an x-intercept, if I want to know the x-intercept, I'm going to plug in 0 for y. That's basically what I'm going to do entirely. Oh, okay. Great. So, plugging in 0 for y. So where there's a y, I'm going to plug in 0. So 0 equals negative 2x plus 5. I'm going to solve for x. So subtract 5. Subtract 5, so I end up getting negative 5 equals negative 2x, divide by negative 2, divide by negative 2, so x equals 5 over 2. That's my x-intercept. Boom. That's it. Then I plug in a 0 for x if I'm trying to find the y-intercept. So y-intercept, I have y equals negative 2 times 0 plus 5, so this obviously becomes 0. So y equals 5. We just found the y-intercept. Easy peasy. All you got to do is plug in 0 for the x or y, depending on which we're trying to get. So find the x and y-intercepts of each equation, then graph the equation using the intercepts. Great. Awesome. So the graphing's pretty nice in this case. X and y-intercepts help with graphing. I'm going to try to find the x-intercept first. This is usually the tough one. X-intercept, so I'm going to plug in a 0 for y, leaving me with 5x minus 1. Now I add 1 over here. So I get 1 equals 5x. So then x eventually equals 1/5. So at 1/5, we've got a little dot. Great. Y-intercept. Y-intercept. I guess I should probably write this straight, but you know what? We're already here. It's okay. Great, so we end up having this. So y equals negative 1. Good, it's my y-intercept. x-intercept, y-intercept, so at y equals -1s right here. So it looks like our graph's going to look like this. Boom. Done. Easy peasy. I don't want to do this one. So we're not gonna. We are going to instead delete this layer. Go to the last bit. There we go. This is what I'm trying to look for. Now we're cooking with oil. Okay. Let's do... Oh, these are so much fun. So standard form. So this is in standard form. Hopefully you remember what standard form was. If you don't, that's okay. Standard form was that ax plus by equals c, right? So standard form is beautiful because I don't have to move anything. I'm not solving for x. Well, I technically am, but whatever. I'll show you what I mean. So I'm trying to find the y-intercept, right? Y-intercept. And in this case, if I want to find the y-intercept, I'm plugging in 0 for x. So I've got 4, 0 minus y equals 8. So I end up getting, this becomes 0, so -y equals 8 divided by -1. Y equals -8. Pretty simple, but the y-intercept is usually simple. So the x-intercept, however, is usually the tough one. So all I got to do is plug in 0 for y. And if you don't know, 4x minus 0 is just 4x equals 8. Divide by 4. X ends up equaling 2. Easy. So at -8, 1, 2, 3, 4, 5, 6, 7, 8. I've got a y-intercept. At x equals 2, I've got an x-intercept. And again, hopefully I didn't really explain this, but I think it's self-explanatory. You've seen it before. The x-intercept is where it crosses on this x-axis right here, okay? The y-intercept is where it crosses on the y-axis right here. Those are the intercepts. Good. And I think that's going to be probably it for today. Hopefully you guys watched this. Hopefully you guys enjoyed it. Bo is passed out now, like completely destroyed. If you wanted to take a gander at him, I think maybe... Oh, let me turn out. Let me see if I can see it. Come on. He's right there. He is completely destroyed. He had a long day today. We played for a long time. But all right. That's it for me. 27 minutes long. Very similar to the last one. A lot of information. Pause it if you have to. And keep on keeping on. See you guys.